All right, now welcome to Lesson 19, Exercise 1. Here's what we need to do. We introduced the Java Math class in the lesson. It's just a collection of mathematical functions. There's tons of them there. One of them is called POW x comma y. So the arguments to this function are two numbers, x and y. They're both doubles, double precision floating point. POW stands for power. So what it's going to do is it'll take the number x and it'll raise it to the power of y. So you could have something like 3 to the power of 4 or 5 to the power of 9 or whatever you want. And it'll compute the answer and return the answer as a floating point number. All right, as a floating point number, as a double precision floating point number. All right, so what we want to do is write a program to calculate a bunch of different powers. So let's keep the bottom number fixed at 1.25, but let's raise it to the first power, to the second power, to the third power, blah, 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 all the way. We're going to increment the exponent from 1 to 20. So we're going to have a whole list of these things calculated, and we're going to format the output as follows. 1.25 raised to the power of whatever we're at, raised to the power of 1, 2, 3, 4, whatever, is equal to whatever. So basically we're going to create a loop. We're going to loop through cycling from 1 to 20, and each time we fall through, we're going to continually calculate the power, the exponent, 1.25 raised to that number, and we'll put it on the screen. So it seems simple enough, and in fact it's not hard. Here's our class declaration. Here's our main method. Inside that we create two variables, both double, because we know that the math functions in the math class, or the methods that are part of the math class, they require doubles as arguments, and they're going to return a double. So let's go ahead and start a for loop. We're going to take the exponent, which remember is what we're trying to increment. We're going to go from 1 to 20, and we're going to continue running as long as the exponent is less than or equal to 20. That's going to do what we're trying to accomplish up there, stopping when we get to the number 20. All right? Then we calculate the answer. The answer is equal to math.pow, which is the power method part of the math class. And the first number, the bottom number is 1.25. It's always the same. And the top number, the exponent, is what our loop variable is. So we're going to continually calculate 1.25 raised to the power of whatever this is as we cycle through the loop. And each time we do it, we're going to print out 1.25 raised to the power of whatever power we're on, so the loop variable, is equal to, and whatever the answer is. So let me save this, and let's run it and see what we end up with, and see if you agree that this makes sense. 1.25 raised to the power of 1 is 1.25. 1.25 raised to the power of 2 is, and so on, and you can see us cycling from 1 to 20, raising 1.25 to the power, to that power, and we can check all this with a calculator, and we're pretty satisfied with the results. So at a top level, that's really what I wanted to show you, is that, you know, the default or the standard floating point variable type in Java is a double, all right? Double precision. That means it's got more bits and can therefore store more digits after the decimal. 99.99% of the time, that's what you're going to use to represent your floating point or your decimal arithmetic. The math functions take double precision numbers as inputs, and they return double precision numbers as outputs. And that's why we declared the answer as double precision. But let me show you something. In this case, the exponent that we're using here, we declared it as a double. And we're looping through exponent is 1 up to 20, and we're incrementing each time we go through the loop. But let me show you a couple things. And these things I find interesting. I'm trying to point out things that you may not necessarily see in a book. First thing, let's go ahead and let's change this exponent to an integer, because that would probably be your first thought. What would happen, let me go ahead and save this, what would happen if we change this to an integer, this exponent to an integer? That means that when we do the power calculation, we have 1.25 and we're raising it to basically an integer, and we already said that these things need to be doubles, right? When the math functions need to be doubles. So let's see if it works. And it turns out that it actually works fine. Nothing really changes between this output and the previous output. So you might say, well, how's that working? I mean, I'm passing in an integer, and you just told me that it requires double. Well, what's going on here is, yes, I'm passing in an integer, but whenever conversion between data types needs to happen, and it's legal, Java will do it automatically for you. So here we're passing it, in this case, we're passing it an integer. This is already represented as double precision decimal here in this number right here that we've typed in, but this is just an integer, and Java converts it to double so that I have two double arguments and I return a double result. Even though I've only declared it as an integer, that's fine. When I pass that value through this function to the power function, a conversion takes place. It all happens behind the scenes. All right. Now, if, for instance, I change this to float, like this, let's see what would happen. And notice the same thing is happening. The output looks good because even though this is supposed to be a double argument, Java is taking the floating point number, which has less precision really than a double. It's converting it to double, it's passing it, it's calculating it, it's giving us the answer. So far, everything's pretty forgiving. Let's put this back to double. Let's see what happens if I try to change the answer to an integer. Whenever I take the power, we notice that the answers we're always getting are decimals. So what's going to happen when I do this? As soon as I try to save it, it underlines this, and it tells me type mismatch, cannot convert from double to int, right? So what this means is that when you do this, this Java thinks is a double, but this is also a double. It's doing the calculation. The result of this calculation is a double precision floating point number, and it's trying to store it in an integer. And it's throwing a red flag, and it's saying you really can't do that because you have a decimal point in your answer, and you're trying to put it into an integer. So when you try to run it, you get this problem here, and you have the option of proceeding if you want, and you have all these problems here. And this is a problem because basically you have incompatible data types. You're not going to be able to convert between double to integer in this instance. All right, so let's go ahead and take this back and say if we put everything back the way it is, we can save, we can hit enter, everything works just fine. All right, now the final thing I want to do is change the answer from a double to a float, right, like this. So now the answer comes back as a double, right, but it comes back as a double, but we're trying to store it into a float variable. So think of it this way. The answer that comes back is a whole lot of bits wide, 64 bits wide. And the answer that we're trying to store it into is only 32 bits wide. So that's not really going to work too well, right? So it's not going to let me compile that. But what I can do if I want to override that and go ahead and tell them, go ahead, I know what I'm doing, go ahead and do it for me, I can cast it, which we've talked about before. I can cast it as a float. This tells me, hey, take your answer, which is double, convert it to float, which means throw away a bunch of bits, and then store the answer. So it's making the left and the right-hand side compatible. So when I hit enter here, when I run it, everything calculates properly. It's just that some of the decimals are truncated off because I forced it to do that for me. I forced it to do that for me. And you know, I bet you can do the same thing with integers. If I do this as an integer, and it gives me that warning, and I say, that's okay, I know what I'm doing. Store it as an integer. Look what it gives me. It gives me the calculation, but it truncates the decimal completely, and it gets rid of everything except for the whole number, because in this case, the math function is returning a double floating point number. This casting here, this parentheses with the int says, convert the result of what's right next to it and change it into an int. Yes, I know that you're going to be throwing away decimal points. Yes, I understand that that's not smart, but do it anyway and store the result in the integer variable, and it's allowed to proceed forward. So let me go and erase all of this and put it back the way we started. This material is difficult for a lot of people to understand, and I'm trying to break it down with a lot of examples. The bottom line is when you're doing floating point arithmetic with any kind of numbers or anything you need to store a decimal point, declare your exponents or your variables or whatever you're doing as doubles. That's going to get you by 99.9% of all of your code. But occasionally you may have to convert between doubles and floats and doubles and so on. And when you do that, you may have to explicitly tell it to do the conversion. And if you ever need to do that, you do it with the parentheses, like this, and kind of tell it to go ahead and do the conversion for you. But in this case, the math libraries that come with Java operate on double numbers, and they return double numbers. So in the barest version of what we're trying to accomplish with this program, this is how you would pull it off.